heterocyclics, and this session, being the first session, we are going to look at introduction to heterocyclic compounds. So at the end of the session, you should be able to give examples of heteroatoms, what heteroatoms are. You should be able to state some general uses of heterocyclic compounds. You should be able to provide systematic names to some saturated heterocyclic compounds. So we'll begin with heterocyclic compounds, yes, but before that we can look at what cyclic compounds in general are. Now these cyclic compounds can be divided into two. You have the carbocycles comprising carbon and hydrogen mainly, and you have the heterocycles comprising a carbon atom in the carbocycle being replaced with a heteroatom. Now the heteroatom can be nitrogen, can be oxygen, selenium, silicon, phosphorus, boron, etc. But mostly they comprise nitrogen, oxygen, and sulfur. Now, a large number of heterocyclic compounds are essential to life because, various heterocycles like alkaloids, antibiotics, some amino acids, vitamins, hemoglobins, and a large number of synthetic drugs and dyes contain heterocyclic aromatic compounds. So they are vital and essential to life. Okay, so now in the nomenclature of heterocyclic compounds, there's saturated heterocyclic compounds. These are two things we need to keep note: the prefix and the presence or absence of a nitrogen in the ring system. Now, whenever there's a heteroatom, which is oxygen, we give it the prefix oxa or ox. If it's sulfur, we give it isa or as. Nitrogen, we give it the tire, phosphorus, phosphor, silicon, silla, and then if it's selenium, we give it the prefix selenous. Now, that being said, the ring system itself is also important, right? So a three-membered ring system with nitrogen in it is given the parent name aridine, right? A four-membered ring with nitrogen present is given the name etidine. However, if you have a five-membered ring with no nitrogen present, just one heteroatom with no nitrogen present anywhere in the ring, we give it the name olan. So please, let's take note of these two approaches: the prefix itself and the parent name, depending on the presence or absence of a nitrogen group. So the next slide, we are going to look at certain typical examples. So conventionally, the heteroatom is assigned position 1, and the substituents are then counted around the ring in a manner so that it gives them the lowest possible numbers. So here is a typical example. This is a 5-membered ring. So in the previous slide, we said a 5-membered ring. We have a name for it depending on the presence or absence of a nitrogen. But here there's a nitrogen here. So we will give it the name azole, right? The parent name becomes the azole. But when we count, we are going to prioritize the oxygen, give it the carbon number 1. So the naming started from the oxygen 1, 2, 3, not the other way around, right? So we don't go this way around, but we go this way around. So we have 1, 2, 3, not 1, 2, 3. No, that will give the nitrogen the number 4. We don't want to do that. So it starts counting from this side. Now oxygen is the heteroatom present, so the prefix oxa or ox. So in the final naming, the name is given as oxazole, right? Oxazole. Now the next one is to look at a situation where the heteroatom present here is nitrogen, and we looked at the name for that as well. So a 5-membered ring, the azole still holds with nitrogen present, so the azole still holds. This is the last parent name. Then the presence of the heteroatom nitrogen is known as the imidazole. So the name becomes imidazole. Now here the heteroatom is S, giving the name tire. And the parent name is a 5-membered ring with nitrogen present, so it becomes thiazole. So please keep note. This is the best way in naming them. While writing the name of the compound, the substituents are placed in alphabetical order. So please don't forget that one as well. The substituents are placed in alphabetical order. Okay, so in the case where the Heterocyclic ring contains more than one heteroatom. The order of preference for numbering is O, S, and N. So please take note of that. The ring is numbered from the atom of preference in such a way that it gives the simplest possible number to other heteroatoms in the ring. So this is basic in organic chemistry nomenclature. So here we count anti-clockwise and not clockwise. Similarly, here we count anti-clockwise, but in this particular case, clockwise or anti-clockwise will still give us the same name. So these are other examples: oxyring, a three-membered ring with just one heteroatom. So the absence of the nitrogen gives us the parent name, urane, and the O is the heteroatom here, which is ox, becomes oxyrane. Now, this is aziridine, three-membered ring with nitrogen present and the heteroatom being the same nitrogen. So aziridine, and this, the name goes on and on and on. So please take note. These are other examples for a perusal.